Hi there, and welcome to this lesson. In this lesson, we'll be learning angles of elevation and depression. Okay, and under angles of elevation and depression, we'll be learning about the angle of elevation. Okay, now as the lesson progresses, anything you don't understand, be sure to get across to your tutor, who would be more than happy to help. And yes, let's jump right into the lesson. So, angles of elevation and depression. Now, what is the angle of elevation? Now, the angle of elevation of an object as seen by an observer is the angle between the horizontal and the line from the object to the observer's eye. Okay, now what exactly is this about? So, angle of elevation. Now, just think of it. Elevation. When you talk about elevation, you talk about something going upwards. Okay, and to understand this, it's basically mainly about sight. Okay, and how we observe things. But let's try out an example here. So, um, here's the Eiffel Tower. Okay, the Eiffel Tower is a very popular figure in Paris, France. Okay, and it's a very tall tower. Okay, and what it is we have this observer. You see an eye there. Okay, so we have this person. There's an eye there, looking at this tower. Now, with this person standing and facing straight forward, basically, we'll observe this angle of they will observe this Eiffel Tower with a horizontal line of sight. Okay, straightforward. Okay, but then if this person tried to look at the top of the tower, okay, this person would have to tilt his head upwards, okay, to look at the top of the tower. Now, basically, the angle of elevation of an object, as seen, the angle of elevation of the top of the tower, as seen by this observer standing at the on the ground, okay, is the angle between the horizontal line of sight, that's the initial horizontal line of sight, and the new line of sight when this person tilted his head upwards to look at the top of the tower. So what we have is we have an angle, okay, between the horizontal line of sight and the new line of sight, and this angle is called the angle of elevation. It's really very simple basically. And if you look closely, you see we formed a right angle triangle. Okay, so we have a right angle triangle. The height of the Eiffel Tower in this case is our opposite. We have our angle in the triangle. We have a 90 degrees. The distance between the observer and the base of the Eiffel Tower is adjacent, and our new line of sight is our hypotenuse. And with this, basically, we often have a number of problems that we can obviously apply trigonometry to solving. Okay, and here's one of those examples, a very simple example. And we have that John observed the top of a tower that's 72 meters high with an angle of elevation of 42 degrees from the horizontal. Now, how far away is John from the foot of the tower to the nearest meter? So what we do, we have this tower here, okay, and this tower is 72 meters high, okay, and we have John standing somewhere here at the bottom of at the base of the tower on the ground basically, and at this time we're not taking into account John's height. We're basically assuming John's eyes are directly level with the base of the tower. Okay, so it's just an assumption there, but sometimes you may be asked to solve with the observer's height. Okay, and it's very important that you take that into consideration. But in this case, we're assuming that the person's initial line of sight is directly in line with the base of the tower. Okay, so we have a line of sight here. Okay, and basically we have going to call this x, which is basically what we're looking for, how far this person is from the bottom of the tower. And then we have he tilted his head upwards to look at the top of the tower, and the angle of elevation was 42 degrees. Now, what we have here, we have our opposite at 72 meters. Adjacent is what we're looking for, and we have our angle. And quite simply, we're going to apply trigonometry, and we're going to be making use of TOA. Okay, so we're going to use tan, and what we have is we have that tan 42 degrees equals 72 over x, okay, TOA, and we just solve that out. We have that x equals 80 meters. Simple, straightforward. So basically, angles of elevation and depression, mathematically, we're basically just doing trigonometry. Okay, it's no different from what you've been learning up until now. But you at this point, you just need to understand how to interpret this type of questions. Okay, very, very important in application of trigonometry, how to interpret this type of questions so you know where the observer is, how the angle of elevation of a given height, okay, and the distance of the observer from the foot of the object basically. So here's another example. Okay, we have an example, example one, and we're told that the base of a tower of 55 meters is 37 meters from point A. Find the angle of elevation of the top of the tower from point A. Okay, so we have this tower, 55 meters, and we have this point A. And the distance between A and the foot of the tower is 37 meters. Okay, very, very simple interpretation. All right, and what we do is we have an observer at point A tilting his head upwards to look at the top of the tower. Okay, and when it done that, we formed an angle of elevation alpha. Okay, and in this case, we're looking to find that angle of elevation. And basically, using trigonometry, we have an angle alpha, we have our opposite, we have our adjacent. We're going to be making use of TOA, and we have the tan of alpha equals 55 over 37, and we have tan of alpha, we'll work that out, we have 1.4865, and to find alpha, we just find the tan inverse of 1.4865. What we have in the end, we have alpha as 56.07 degrees. Simple, straightforward. Okay, let's go ahead and do another example. Example 2, like I said, it's basic trigonometry. Okay, really, really no extra, no different from what you were learning. It's just knowing exactly how to apply what you know already to solving angle of elevation questions. Okay, and interpreting the questions to create your right angle triangle. So now we have this here. We have the Statue of Liberty. The Statue of Liberty, a very, 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 very important monument in the United States, the Statue of Liberty. And let's bring it up. Basically, we have an image here, and yeah, that's your Statue of Liberty. Very, very, very tall. Okay, and what we have is we have the actual statue. If you look at the statue, it's resting on something. Okay, something is pretty high. It's the pedestal. That's what it's called. It's resting on the pedestal. And now let's read our question. We have the Statue of Liberty stands on a 150 feet pedestal. Okay, so we have this pedestal as 150 feet. Okay, now from a point 250 feet from the base of the pedestal, it says, so we have this point A, and this point A is 250 feet from the base of the pedestal. The angle of elevation, so we have somebody at A looking right to the top, okay, looking to the torch, okay, the angle of elevation to the top of the Liberty's torch. If you look closely, the statue is holding up a torch, okay, and the torch is the highest point of the statue. So we have to the Liberty torch is 70 degrees, and then we've been asked to find the height of the statue, okay. And yeah, this is very easy, very straightforward. If you look closely, you'd find that we formed a right angle triangle. It's not all together, but then what it is we have adjacent at 250 meters, opposite as 250 feet, opposite as 150 plus x feet, and then we have our angle in the triangle at 70 degrees. And we just go ahead and solve our right angle triangle there. We have opposites and adjacent, so what we have is we have that tan of 70 equals x plus 150 over 250, and where we just work that out and we cross multiply, we have x plus 150 equals 250 times 70, and x plus 150 is equals 250 times 70 is 687, and we work that. What we have in the end is we have that the height of the statue is 507 feet. Simple, straightforward. Okay, now one final example. Okay, example. And what we have is we have Jake and Chloe observe the top of a tree with angles of elevation 60 degrees and 45 degrees respectively. If Chloe is 4 meters farther away from the tree, find the height of the tree. Okay, now this one is very interesting. Okay, let's just get our diagram drawn first. Because what we have is we have these three, and we're looking for the height of the tree. Okay, and basically we don't know the height of the tree. We're looking for the height of the tree, and we have our horizontal. Okay, now on this horizontal we have 2 points. Okay, because we have two observers in this case. And the first observer is, we have a 90 degrees angle. The first observer is Jake. Okay, and from this point where Jake is standing, and we have Chloe, basically Chloe on the other end. Chloe is 4 meters farther away from the tree than Jake. And from this point where Jake is standing, Jake observes the top of the tree with an angle of elevation of 60 degrees. Now Chloe does the same, okay, with an angle of elevation 45 degrees. And one final important bit of information that we're provided with is we're told that the distance between Chloe and Jake, Chloe is 4 meters farther away from the tree. Okay, so the distance between Chloe and Jake is 4 meters. And that's all the information we've been given. Now, we've been asked to solve for the height of the tree. Now, this is a very, very interesting question because at this point we don't have enough parameters to solve for, because we do not have, basically we do have two triangles, two right angle triangles, but we don't have enough information to solve for the height of the building. Because if we could have done so simply if we knew how far Jake was from the tree, but we don't know that, and we're actually going to call out y. Okay, so we don't know that, and or if we knew how far Chloe is from the tree, we don't know how far Chloe is from the tree. We just know that Chloe is 4 meters farther away from the tree than Jake. So Chloe is 4 meters away from Jake. So how would you go about solving a question like this? Okay, so we have that distance of Jake's distance from the tree is y. Okay, and I tell you that Chloe's distance is y plus 4. Okay, because basically if Jake is y away from the tree and Chloe is 4 away from Jake, basically you add that together, you have that Chloe is 4 y plus 4 away from the tree. Okay, now we have two triangles here. Okay, Jake's triangle is the smaller triangle. Okay, and Jake's triangle we have 60 degrees, and the height of the tree as x, and the adjacent, the distance of Jake from the tree is y. Okay, so our adjacent is y, opposite is x. And we have another triangle, Chloe's triangle. Chloe's triangle is a bigger triangle. Okay, the full triangle from the tree all the way down to Chloe. Okay, and in Chloe's triangle we have 45 degrees. Okay, Jake's triangle is inside Chloe's triangle. So for Chloe's triangle we have 45 degrees. We have her adjacent as y plus 4 and opposite as x. So we're just going to draw out the information for Jake and Chloe. Okay, I will start off with Jake, and basically what we have is we have, using trigonometry, x, which is our opposite, divided by y, which is our adjacent, will give us the tan of the angle of the triangle. So tan 60 equals x plus y. Okay, and we do the same for Chloe. Tan 45 equals x over y plus 4. Okay, now we're going to solve simultaneously. Okay, and if you're following very quickly, you probably would have noticed that already. But basically, let's work it all out. And what we have is we have tan 60 equals x plus y, x over y, and then tan 60 is 1.732. So 1.732 equals x over y. Tan 45 is 1. So 1 equals x over y plus 4. And we have that x equals, and cross multiply there, you have x equals 1.732y, and you also have that x equals y plus 4. And if you look closely, you have equation 1 and equation 2. And now you're going to quite simply solve simultaneously. Okay, so we solve simultaneously to get a result. And my favorite method for solving simultaneous equations, I have that x equals 1.732y and x also equals y plus 4. You would agree with me that if that's the case, 1.732y would equal y plus 4. Okay, and then we just go ahead and move our terms, move y over to the left. We'll subtract from 1.732y. We're left with 0.732y. We divide both sides by 0.732 and we end up with 5.46 meters. So Jake's distance from the tree is 5.46 meters. And then to find the height x, to find x, we just substitute y back into any of the formulas, and what we have is we have x equals y plus 4, x equals 5.46 plus 4, and we have that x equals 9.46 meters, and that is the height of our tree. And yes, that would bring us to the end of this very interesting lesson, angles of elevation and depression. Okay, like I said, it's basic trigonometry. Okay, you just need to know exactly how to interpret the questions, understand exactly what an angle of elevation is, and interpret the questions and know how to get your right angle triangle from the question. And from that point on, it's just basic, simple trigonometry. Okay, but it's very important you understand exactly what the question is asking. Like I said, sometimes you may be told to neglect the height of the observer. There are times when you're told to consider the height of the observer, and all of that. You have cases like this where you have the Statue of Liberty with a pedestal, okay, and you have 150 meters and then plus x, so things like that. So there are different ways the questions can come at you, and but basically it's still the same principle. Just interpret, form your right angle triangle, and solve using your trigonometric ratios. And yeah, you can go ahead now and attempt questions on the worksheet. Bye for now.